And we're good to start through the slides. You're first. Go for it.
Okay. Hi everyone. I'm Jose Alcalá. I'm a PhD student from the University of Alcalá, Madrid, Spain. And we are presenting here is a load identification. So actually we are using a anti-reactive distortion power for our time as a load signature. This cataloging information. We compress this information using principal component analysis, and this compression is done in different ways depending on the appearance type. So if we compress a microwave, we use a transformation matrix. We try to compress a heater with the transformation matrix. The microwave, we get a different result. So using this, we can discriminate one from another. Actually, a high accuracy, around 98%. Yeah, that's pretty much. Thank you very much for listening. I'm looking forward to getting your thoughts later.
Awesome. Thank you.
How much?
You still have 10 seconds. Sorry.
Okay, hi everyone. So we've done a demo outside to illustrate how our disaggregation algorithm works. So if you want to discuss about algorithm, service, or even IT and big data technology, you can come and see us at our demo.
Okay, that was great. Thank you very much.
Hello everyone, I'm Dorian Turin. I'm the co-founder and CTO of SmartSupports. It's a startup based in Paris. And we offer disaggregation mainly for commercial and industrial buildings, large buildings with highly dynamic load curves. I started to work on disaggregation in 2008 with high frequency device. So we have our own hardware. We develop disaggregation algorithms, software, and web platform to visualize the data. Our algorithms are self-learning, so we have developed something which enables the disaggregation of any building without knowing almost anything about it. So we're just listening to the electrical signals, and we extract the features that we can recognize afterwards. And so far, we have collected 500 years of high-frequency data on which we try to validate the disaggregation technology. And we've been certified by the third-party lab at an accuracy of 95 to 99% on the field, so not in the lab, on the field, to make it deploy in large buildings, and today in 20 countries. Thank you.
Awesome. Thank you very much.
Hi everyone, we are quite to summarize as posters, we are using NILM in many Windows applications. First of all, we're using NILM to synchronize our usage of the client and measuring the current voltage in long term allows to monitor the quality of our electrical network. So we use NILM to identify the best of the bad appliance who causes the noise, the loud quality in electrical network, and we continue to integrate in this topic. We integrate more algorithm, more data processing to reach the preventive maintenance to predict the trouble and avoid the damage appliance. And the last application, we use NILM to model the energy topology of the building. We have some research in this domain, and we need to investigate more algorithms. Thank you.
Thank you very much.
Hello, my name is Celine. I'm a PhD student from the London Law for CDT for energy demand. So as we know, that in order to decompose the load, total load into its components, we need a thorough analysis of individual appliances, etc. What I'm looking at is appliance usage patterns and power characteristics and the power levels that the appliances can adopt. Those of you from UK might know the dataset Household Electricity Survey, which monitored 5,000 appliances in 250 homes based on 2 to 10 minutes resolution. So I did some data analysis on that, and I have some interesting plots and histograms about the appliance profiles and the durations and frequency of usage, etc. So if you're interested, come and have a chat with me afterwards. Thank you.
Thank you.
Yes, hello, my name is Florian Liebert. I'm with the Institute of Signal Processing and System Theory of the University of Stuttgart. And what I'm doing is I'm looking at different query strategies for active learning in event-based NILM. As you know, if you're doing supervised learning, you need a lot of label training data, and well, not every data point is as valuable as the others. So what we want to do is we want to find the data points important for the training and label only those data points. One key aspect of active learning is to choose the right query strategy. So how to choose the samples you have to label. Here you see one result on the blue data set, phase A. If you want also to see also phase B, then come take a look at my poster. Thanks.
Thank you very much.
Hello everyone, we are SmartP, and we provide energy monitoring and transparency for commercial buildings. And we noticed that disaggregation is one of the tools to achieve that and make it easier. And that's why we recently developed this interactive energy explorer. It's pretty new. And what it enables is for the users to really interact with their energy data, their energy graph, and use unsupervised disaggregation algorithm to come up with understandable energy patterns so that they can react with them, they can play with them, they can label those and later track those, and basically create a playground where they can enjoy their energy data. So if you would like to give it a try, please join us around the corner and be the first users to give us feedback. Thank you.
Awesome.
Yeah, hi.
No slides.
No slides for me. I'm Lili Bats, and my work is concerning appliance recognition, and therefore I'm using high frequency data. More specifically, I extract a time frame from the voltage and current, and from that I create a VI trajectory. And from this continuous VI trajectory, I create a normalized picture. And like already mentioned today, pictures can be best classified when using neural networks. So I trained a neural network that takes as input this normalized picture and can predict which appliance is turned on or off. So I didn't prepare a slide, so if you want to see a fancy picture, come to my poster.
Thank you.
No slide for me there. So yeah, I don't know about you, but I woke up very early and it's not really my thing, so sorry in advance if it don't make too much sense. But I wanted to tell you a few things about Fruidia. It's a company I created a few years ago, and we are focusing on two things. We're doing two things. It's one of them is doing sensors, so it's optical readers. You can plug in a real meter, and since I'm a vendor, I have a product with me, so I can show you. So it's kind of I don't know if you'll see from the, it's really tiny. It's something you can just stick on a meter, existing meter. It could be a Nord electromechanical meter, you see what I mean, or a new meter with a flash head, and it works fine. And the other thing we're doing, but it's not completely related, it's a NILM API, so we provide it and we can use it with data that are not coming from this thing. And the last thing I wanted to say about this workshop is why I came here. Well, I'm happy with what I saw, and I came here to get a feel of the field, and so I think that was very interesting because there are startups, people from academies, and also big companies, so that was great. And the other thing I came for is to try to make partners with, create partnerships with academics or companies, because I think we really need to work on collecting data, but also work on improving the product. So we have data, we have products to collect new data, and we just want to partner and try to improve. So thank you.
Thank you very much.